Bismillahirrahmanirrahim. This is lecture number 5. We have to find unit vector which is perpendicular to the given vectors. For example, you are given a vector u, it is equal to I plus j, and another vector v which is equal to j cap plus k cap. And we have to find unit vector which is perpendicular to u and v both. So first of all, we find a vector which is perpendicular to u and v. For example, this vector is u and this vector is v. A vector which is perpendicular to u and v both, it is suppose R, and we can find this vector by using u cross v. Vector R, which is u cross v, it is perpendicular to u and v both. Now direction of this vector is unit vector which is perpendicular to u and v both. So for that, first we find vector R which is equal to u cross v. It is equal to determinant of order 3 by 3 of first row I j k, second row a1 a2 a3, third row b1 b2 b3. a1 a2 a3 are the components of first vector, means vector u, and b1 b2 b3 are the components of second vector, vector v. Now it is equal to ijk, a1 a2 a3 are 1 1 0 and b1 b2 b3 are 0 1 1. Now expand this determinant. For I cap, its multiple determinant is 1 0 1 1 minus j cap, its multiple determinant is 1 0 0 1 plus k cap, its multiple determinant is 1 1 0 1. Now it is equal to I cap multiplied by 1 minus 0 minus j cap into 1 minus 0 plus k cap 1 minus 0. So it is I cap into 1 minus j cap into 1 plus k cap into 1. Now it is equal to I cap minus j cap plus k cap. It is vector R. It is basically this vector is perpendicular to vector u as well as it is perpendicular to vector v. Now we find magnitude of this vector. We use magnitude formula. Magnitude of r is equal to square root of 1 is x square plus y square plus z square. It is equal to square root of 1 square plus minus 1 square plus 1 square. It is equal to square root of 1 plus 1 plus 1. It is equal to square root of 3. Now, vector r is equal to magnitude of vector r with its magnitude, with its direction. Now, n cap is equal to vector r divided by magnitude of this vector. Vector r is equal to I cap minus j cap plus k cap, and magnitude of vector r is equal to square root of 3. Can be written as 1 upon square root 3 I cap minus 1 upon square root 3 j cap plus 1 upon square root 3 k cap. It is the direction of vector r. Because vector r is perpendicular to u and v both, so this unit vector is also perpendicular to u and v both. This is how we find unit vector which is perpendicular to the given vectors. Now come to next question, question number 11. We have to find area of triangle ABC if AB and C are given. If A is equal to 2, 1 minus 3, it is 2I cap plus j cap minus 3k cap. B is equal to 1, 1, 0 equals to I cap plus j cap plus 0k cap means 0, and C is equal to 1 comma minus 3 comma 2 equals to I cap minus 3j cap plus 2k cap. Now for finding area of triangle ABC, we use area of parallelogram formed by AB and C. First we find vector from A to B, then we find vector from A to C, now parallelogram formed by these vectors is actually like this. Now half of area of parallelogram it gives us area of triangle ABC. For that we find vector which is perpendicular to these vectors, vectors AB and vector AC. this vector AB cross AC is perpendicular to AB and AC both. It is the direction, and its magnitude, it gives us area of this parallelogram. So area of triangle ABC is equal to half of area of parallelogram. Vector AB cross vector AC, this vector is perpendicular to component vectors, and its magnitude, it is area of parallelogram. Half of magnitude of area of parallelogram, it gives us area of triangle ABC. So first we find vector from A to B. Vector from A to B is B minus A. B is equal to 1, 1, 0. A is equal to 2, 1 minus 3. Which is equal to 1 minus 2, 1 minus 1, 0 minus into minus 3. It is equal to minus 1, 0, 3. It is equal to minus I cap plus 3k cap. Secondly, we find vector from A to C, which is equal to C minus A. C is equal to 1 minus 3 to minus A is equal to 2, 1 minus 3. It is equal to 1 minus 2 minus 3 minus 1, 2 minus into minus 3. It is equal to minus 1 minus 4, 5. It is equal to minus I cap minus 4j cap plus 5k cap. Now we find vector AB cross AC. It is equal to determinant of order 3 by 3 of first row ijk, second row A1, A2, A3, of third row B1, B2, B3. Now ijk, A1, A2, A3 are the components of first vector. Minus 1, 0, 3, B1, B2, B3, minus 1, minus 4, 5. I expand this determinant. I cap, its multiple determinant is 0, 3, minus 4, 5, minus j cap, its multiple determinant is minus 1, 3, minus 1, 5, plus k cap, its multiple determinant is minus 1, 0, minus 1, minus 4. Now it is equal to I cap into 0 minus into minus 12, so 0 plus 12 minus j cap into minus 5 minus into minus 3 plus 3 plus k cap into 4 minus 1 into minus 4 is 4 minus 0. It is equal to 12 I cap minus 2 into minus j cap plus 2 j cap plus 4 k cap. Now we find magnitude of this vector by using magnitude formula. Magnitude of AB cross AC, it is equal to square root of x square plus y square plus z square, square root of 12 square plus 2 square plus 4 square. It is equal to square root of 144 plus 4 plus 16. It is equal to square root of 164. It is equal to square root of 2 into 2 into 41 equals to 2 square root 41. It is area of parallelogram formed by AB vector and AC vector. Now come to area of triangle ABC. It is equal to half of area of parallelogram formed by AB vector and AC vector. It is equal to half of 2 square root of 41. So it becomes square root of 41 square units. One thing more, we can also calculate area of parallelogram, area of triangle ABC by using other vectors. Suppose A, B and C are the same points. Find BA vector, find B to C vector, B to A vector plus and B to C vector. So they form a parallelogram like this parallelogram. We can also find area of triangle by using these two vectors. So area of triangle ABC is equal to half of magnitude of B to A vector cross B to C vector, or Suppose A, B and C are the same points. If we find C to A vector and C to B vector, the parallelogram formed by these vectors is like this. Again we can find area of triangle ABC by using this formula. Area of triangle ABC is equal to half of area of parallelogram formed by CA and CB. It is CA vector cross CB vector. Now, next question. We have to find vector which is perpendicular to the plane through the points P1, P2 and P3. If P1 is equal to 1, 3, 5, P2 is 2, minus 1, 3 and P3 is minus 3, 2, minus 6. Now question is, find a vector which is perpendicular to the plane through the points P1, P2 and P3. Now to find vector which is perpendicular to the plane, first we find vector from P1 to P2 which is equal to P2 minus P1. It is equal to 2 minus 1, 3 minus 1, 3, 5. It is equal to 2 minus 1, minus 1 minus 3, 3 minus 5. It is equal to 1 minus 4 minus 2 equals to I cap minus 4j cap minus 2k cap. Now find vector from P1 to P3 which is equal to P3 minus P1. P3 is minus 3, 2, minus 6 and P1 is 1, 3, 5. Now it is equal to minus 3, minus 1, 2 minus 3, minus 6, minus 5. It is equal to minus 4, minus 1, minus 11. It is equal to minus 4 I cap minus j cap minus 11 k cap. Now vector which is perpendicular to the plane is, suppose R, it is equal to P1 P2 cross P1 P3. It is equal to determinant of order 3 by 3 ijk a1 a2 a3 b1 b2 b3 it is equal to determinant of ijk a1 a2 a3 are the components of first vector p1 p2 which is 1 minus 4 minus 2 and b1 b2 b3 are the components of second vector which is p1 p3 minus 4 minus 1 minus 11. I expand this determinant with respect to first row minus 4 minus 2 minus 1 minus 11 minus j cap into 1 minus 2 minus 4 minus 11 plus k cap into 1 minus 4 minus 4 minus 1 it is equal to I cap into 44 minus 2 minus j cap into minus 11 minus 8 plus k cap into minus 1 minus 17. It is equal to I cap into 42 minus j cap into minus 19 minus 1 minus j cap minus 11 minus 9 is minus 19 plus k cap into plus k cap into minus 17. It is equal to 42 I cap plus 19 j cap minus 17 k cap. It is the vector which is perpendicular to the plane. Next lecture, we will discuss scalar triple product, and by using scalar triple product how we find volume of parallelepiped. Next lecture will be an important lecture. That's all.